So we learned how to solve a log equation when all the terms are in log, but sometimes we get an equation of the type where there is one side there is log and other side it is constant. So we can apply the definition of log. Remember that log of x with base b is equal to k, meaning what should b be raised to get x, that is k. So that means x is equal to b raised to power k. So let's see, we have the first step is to isolate log term on one side and everything else on the other side. Example number 8, part A. 4 times log of 2t minus 7 basis 3 is equal to 8. The first step is to isolate log. That means we'll divide both sides by 4. We will get log of 2t minus 7 basis 3 is equal to 2. Now let's use definition of logs. We will have 3 should be raised to 2 to get 2t minus 7. So 3 raised to power 2 should be equal to 2t minus 7. So we have 3 raised to power 2 is 9 is equal to 2t minus 7. We can solve it by isolating t. Add 7 on both sides. 9 plus 7 is 16 is equal to 2t. Divide by 2 on both sides. So we have t is equal to 8. And as mentioned earlier, you should always check your answers by plugging t back in the original equation. So I'm going to leave that to you guys. Let's start with part B. Now left hand side is a single log term and the right hand side is a constant. So I can apply a definition directly. So using definition of log, we can say 5 should be raised to 2 to get the argument, which is 3x plus 1. So we have 25 is equal to 3x plus 1. Isolate x on both sides by subtracting 1. So we have 24 is equal to 3x. Dividing both sides by 3, we have 24 by 3 is equal to 8. So solution to this equation would be 8. I'm going to let you guys check your answers back in the equation. Let's look at example number 9. Again, we have one log term in one side and other side is just constant, but this is common log. So when I see something like this written, I know even if the base is not written, this is 10, right? So by definition, we have 10 raised to power 2.6 should be equal to W plus 47. So W should be equal to 10 raised to power 2.6 minus 47. We can use our calculators to do that calculation. 10 raised to power 2.6 minus 47. It is 351.11 rounded off. So that is your solution to the problem. Example number 10. Now there are some log terms and there is some constant term which is 3. The first step would be bring all the log terms on one side. Log of x square minus 9, the base is 4, minus log of x plus 3, the base is 4. I'm going to take 3 on the other side. When you add 3 on both sides, it will become positive. Now the base is same, so I can use quotient property. We have log of x square minus 9 divided by x plus 3, the base is 4, is equal to 3. Now we can apply the definition, use definition of log. The base is 4, so 4 raised to power 3 is equal to x square minus 9 divided by x plus 3. If you remember, 4 raised to power 3 is 64. If you remember, x square minus 9 can be factored as x minus 3 times x plus 3. And I don't want x to be equal to negative 3 because then the denominator becomes 0. So I can cancel that. So we have x minus 3 is equal to 64. And then from here x would be equal to 67. And you can always check the answer by plugging back into your equation. Let's look at part B. Log of x plus 6 base 3 minus log of x minus 2 with base 3 is equal to 2. So first step, I can use quotient property, and this left hand side will become log of x plus 6 divided by x minus 2, the base is 3, is equal to 2. So using definition of log, the base 3 should be raised to 2 to get the argument, which is x plus 6 divided by x minus 2. So we have 9 is equal to x plus 6 divided by x minus 2. We can use the cross multiplication. 9 times x minus 2 is equal to x plus 6. 9x minus 18 is equal to x plus 6. Isolate x on one side, so 9x minus x is equal to 18 plus 6. 9x minus x is 8x is equal to 18 plus 6 is 24. X would be equal to 3. Example 11. A couple invests $8,000 in bond fund. The expected yield is 4.5% earning, reinvested monthly. Use this formula to write a model representing the amount A in the account after 3 years. So we are given with the principal, it's investing $8,000, and the R interest rate is given to be 4.5%, which in the decimal number would be 0.045. You can divide by 100 to get that. Here in this sentence, it's also saying reinvested monthly. That means the number of times interest is compounding is monthly. So n would be equal to 12. So we have to write an amount function which is based upon t, which is equal to p, which is 8,000 now, times 1 plus r, which is in this question 0.045, divided by n, which is 12 raised to the power 12t. That is the first part. They are just asking us to write the amount function for t years. Part B, determine how long it will take the initial investment to double. That means double meaning amount would be equal to double of 8,000, which is $16,000. So we want to, question is, we want to find time when amount is 16,000. So we already have the function. We can say 8,000 times 1 plus 0.045 divided by 12 raised to power 12t is equal to 16,000. We need to solve it for t. So the first step, to divide both sides by 8,000. When I divide both sides by 8,000, the right hand side here will become 2, and the left hand side, this will cancel, and inside we have, let's just calculate that to make our life easier. Divide by 12 plus 1. So we have 1.00375 raised to the power 12t. Now this is a form of exponential equation, but we cannot make the bases same on both sides, right? What do we do then? We do take log on both sides. We can take any log, natural log or common log. So let's take natural log on both sides. What will happen? Natural log of 1.00375 raised to power 12t is equal to natural log of t. Now, because of the power property, this comes down out. So we have 12t times natural log of 1.00375 is equal to natural log of t. Only unknown is t. So t can be isolated by dividing both sides by 12 times natural log of 1.00375. So natural log of 2 divided by 12 also divided by natural log of 1.00375. So we have 15.043. So roughly it will take 16 years to double the investment. Another application problem. Suppose that sound at the rock concert measures 124 decibels. Use the formula L is equal to 10 times log of I divided by I naught to find the intensity of the sound, that is I. The variable L represents the loudness of the sound in decibels and I naught is 10 raised to power negative 12. So part A, L is given to be 10 times log of I divided by I naught. The sound at the rock concert measured 124 decibels. That means L is given to be 124 decibels. I naught is given to be 10 raised to power negative 12. The question is to find the intensity. I is unknown. So let's plug in everything which we know. L is 124 is equal to 10 times log of I divided by I naught is 10 raised to power negative 12. So the first step we need to find I. So it's a log equation. We can divide both sides by 10 to get rid of 10. We need to isolate log term. That will be 12.4 is equal to log of I raised to power 10 I divided by 10 raised to power negative 12. Now the base is not written here. That means it's a common log with the base 10. So using log's definition, we can say the base 10 raised to the power 12.4 is equal to I divided by this. So we can cross multiply and I would be equal to 10 raised to power 12.4 times 10 raised to power negative 12. That would be 10 raised to power 12.4 minus 12, 10 raised to power 0.4. We can use calculator. 2.51. So intensity is 2.51 approximately, and it's given in, this is the unit, W by meter square. That is the first problem. If the threshold at which the sound becomes painful is 1 W per meter square, will the music at the concert be physically painful? So we can, our threshold generally is 1 W per meter square according to the question. But in this case, the intensity is this, right? So that is way more than 1. So the question is, will the concert be painful? So we will say yes, intensity is more than 1 unit. So it will be painful to hear.